Hey everyone, thanks for tuning in. Today we'll be looking at how to actually use the trigonometric identities. If you're unfamiliar with any of the identities, I highly suggest that you take a look at my previous video that I've made. It just basically highlights all of those identities, namely the reciprocal identities, the ratio identities, and the Pythagorean identities. Because quite frankly, if you don't know what they are, you're going to be screwed for this. So go check that out and then come back to this video. So in this video, we'll just be looking at 4 examples that I've picked and just the basic premise of how to solve these sort of questions, because they can be tricky, although once you go through enough practice and I share with you a few of my tips, then hopefully you should be quite solid in these types of questions. So let's begin. The first question we look at says prove that tan theta times cosec theta is equal to sec theta. So the basic premise of these questions is to start off with the left hand side and eventually get it towards the right hand side. So the first step that I'm going to be doing is I'm going to be saying, well, I'm just going to recite what the left hand side is equal to. And I'm going to say the left hand side is equal to tan theta cosec theta. Okay, and throughout these questions, you kind of want to be looking ahead to where you need to go. And I need to prove that it's equal to sec theta. So sec theta I know is going to be in terms of cos, okay, because of the c. And cosec is sine, and tan theta I know I can write in terms of sines and coses. So that's exactly what I'm going to do to get me one step closer towards my solution. Because at the moment, our right-hand side doesn't involve any tans, doesn't involve any sines, it only involves causes. So I'm going to rewrite this and I'm going to say, well, tan theta is equal to sine theta over cos theta times cosec theta, which by definition is 1 over sine theta. And what I notice, nice and easy, is I can combine these two fractions. So this is sine theta over sine theta cos theta, and the sine thetas cancel, and that leaves me with 1 over cos theta, which gets me to where I need to go, in that it's sec theta. And then I say right hand side. Then you make a statement, as required, or if you want to be a bit arrogant, personally I do enjoy therefore QED. It means something for Latin, but I don't know, quite easily done is the acronym I like to use. So yeah, basically we've started with the left hand side and we've really tried to strip it down into its fundamentals. And in doing so, we've been able to cancel the signs and end up with what we need. Okay, so this is quite an easy example. Another example that we'll look at is this one here. So we need to prove that cos theta plus cot theta times sec theta is equal to 1 plus cosec theta. So maybe this is a little bit, I guess, deeper than the previous question. So how do we do this? Well, yet again, we start with the left-hand side, and literally we just regurgitate what the left-hand side is. Okay, so now I'm looking, and I see I've got cos, I've got cot, and I've got sec. And where do I want to end up? I want to end up with, a 1 and a cosec. So a nice easy way to do it is whenever I see cot or tan, I like to simplify it into sines and coses, especially if I need to get it into something which involves sines or coses. Because at the end of the day, cosec theta is basically 1 over sine theta. So it's basically just sine theta. So we want to order this in such a way that we can get it into closer to sine theta. So this is going to be equal to cos theta plus, now cot theta by definition is cos theta over sine theta, okay, and times by sec theta. Now generally, whenever I see some sort of reciprocal trig identity, I like to just re-express it in its simplest term, in that it's 1 over cos theta. And by doing this, I can really just multiply my fraction. So what I've ended up with is I can go cos theta times 1 over cos theta, and that's just 1. Now cos over sine theta times 1 over cos, and what you should notice is that the cos's will cancel. If you can't notice, I'll just take it slow. So cos over sine times 1 over cos leaves you with cos theta over sine theta, and then cos theta pops in on the bottom, and we can cancel the cos's, and that leaves us with 1 plus 1 over sine theta, which is 1 plus cosec theta, okay, which is equal to our right hand side as required, or therefore it was quite easily done. Okay, hope that makes sense. We'll take a look at 2 more examples, and they ramp up from here. So those previous 2 examples are fairly straightforward. Okay, you really want to master those types of examples, and it's these later 2 examples which might get a little bit tricky. So let's take a look. So the next question we look at is this one here, which it's a bit of an ugly one to look at actually. So it says 2 cos squared theta minus cos theta all over sine theta cos squared theta minus sine cube theta. Now all of this is equal to cot theta. Okay, so where do we start? Well, we start just by regurgitating the left hand side as per normal. So it's equal to 2 cos cube theta minus cos theta all over sine theta cos squared theta minus sine cube theta. Mind you, this type of question here would be worth about 3 marks. Okay, so where do we need to go from here? First off, these cubes right here are quite ugly. Okay, and what I can hopefully realize is that I can factor them out. I can factor this cos cubed out by a cos theta, because I can factor this and this. And then on the denominator, I can factor out a sine theta. Okay, so that leaves me with cos theta outside of 2 cos squared theta minus 1 all over sine theta outside of cos squared theta minus sine squared theta. Okay, now one thing I'd like you to notice is that, remember, we should always be keeping in mind our goal, and our goal is cot theta. And remember, cot theta is basically cos theta over sine theta. And what I notice is that I've already got a cos theta over sine theta here, cos theta over sine theta, which should hint to me that this over this should be 1, okay? Because essentially cos theta over sine theta times 1 will get me that cot theta that I need. So what I'm going to do is just separate the fraction. Okay, so now hopefully I've found my goal, and my goal is to make this fraction over here that I'm writing, so this one over here, is to make this fraction 1. Okay, so how am I going to do that? That's the big question. And generally, whenever you see cos squared or sine squared, immediately you should know that you're going to have to use the Pythagorean identities, okay? Namely, you're going to have to use the identity that cos squared theta plus sine squared theta equals 1. This is your main identity that you really need to remember, okay? Now, from this identity, I can derive by subtracting cos squared theta on both sides. I can say sine squared theta is 1 minus cos squared theta. Okay, that's pretty nice. So now I can rewrite my denominator, and I can say, well, it's 2 cos squared theta minus 1 over cos squared theta minus, now what did I just say sine squared theta was? And I said it's 1 minus cos squared theta. Okay, just like that. Now, remember our goal, we want to make this 1. Okay, so it's equal to cos theta over sine theta times 2 cos squared theta minus 1. Now on the bottom, if we just expand out that negative, we get cos squared theta. Negative times 1 gets us negative 1. And negative times negative cos theta gets us positive cos squared theta. Okay? And from here, hopefully we should see what's going to happen. But it's going to be equal to cos theta over sine theta times 2 cos squared theta minus 1 over, now it's cos squared theta plus cos squared theta, which is 2 cos squared theta. And then we've got this left over minus 1. And there we go. 2 cos squared theta minus 1 over 2 cos squared theta minus 1 is exactly what we needed, which was times 1, which equals cos theta over sine theta, which equals cot theta, which equals our right hand side that we needed to prove. Okay? And we make our little statement, therefore it was, quite easily done. I guess, the arrogance you gotta have to write that sort of stuff. It takes a lot of balls, and it's a bit embarrassing if you don't get the question, especially. Okay, so make sure when you write QED, you actually get the question right. So this is the final question here, question 4, and we've got fractions, and we've got coses, we've got tans, we've got cots, and we need to just say all of this nonsense is equal to sine theta plus cos theta. Yet again, start with the left hand side, just regurgitate what it is. Tan theta, cos theta over 1 minus tan theta plus sine theta over 1 minus cot theta. And I notice I've got coses and sines, and I've got tans and cots. And where do I want to get to? I want to get to sines and coses. So all these tans and cots are quite irrelevant, okay? I want to convert them into sines and coses because eventually that's where I need to go. So I'm just going to do that straight away, because the sooner we can do that, the better it's going to be. By definition, tan theta is sine theta and cos theta, and cot theta is equal to cos over sine. Just like that. Okay? Now, by rewriting the denominator, I can essentially, what's 1 minus sine theta and cos theta? And that's equal to cos theta minus sine theta over cos theta. Okay? Hopefully you can see how that works. Basically, you just want to make them the same denominator. And essentially, this is 1 over 1. Okay? So the common denominator you're going to have is cos theta. So what do you need to do to this denominator of 1? And it's times by cos theta. Okay? Using a similar argument, you can get something for this denominator over here. And you say it's sine theta minus cos theta over sine theta. Okay? Now, going further, I can get from this line to say it's equal to cos squared theta over cos theta minus sine theta. And basically you can just bring that cos up. Okay? If you're having trouble with how this actually works, well, think about what the fraction means. And it's essentially, we're saying it's cos theta divided by cos theta minus sine theta all over cos theta. Okay? And that's basically just cos theta times cos theta over 1, let's write it, times cos theta over cos theta minus sine theta, which is equal to that. Hopefully you can see how it equals that then. And by a similar argument, we say this fraction over here, this nonsense, is sine squared theta over sine theta minus cos theta. Okay? Now, what I want to do is essentially combine these fractions. And it's probably going to be a bit messy to times this fraction by sine minus cos and this one here by cos minus sine. Instead, what I'm going to do is what I should notice is that the denominators are so close to being equal. They're so close. As a matter of fact, this one is positive cos, this one's negative, and this one's negative sine, and this one's positive sine. So what I can do is I can be a bit sneaky here, and I can say, I can take the negative out of the denominator and shift it to the front, so this plus becomes a minus, and it's sine squared theta over, now if I take a negative out of the denominator, it becomes then cos theta minus sine theta. So take a negative out of negative cos and then get positive cos. Take a negative out of positive sine and it becomes negative sine. And now, by doing this, I have the same denominator. And we should know how to add and subtract fractions, okay? If you're doing this kind of maths, it's a bit pathetic if you don't know how to add and subtract fractions by now. So we add and subtract the fractions, like so. And really, all that's left to do is just simplify. Now, you always want to be, whenever we have these cos squareds and sine squareds, first off, you want to be looking out for the Pythagorean identity, namely the one we used in question 3, that cos squared theta plus sine squared theta equals 1. But more often than not, if you get something like cos squared theta minus sine squared theta, it's very useful to use the difference of two squares. Okay, so this simplifies the cos plus sine theta, cos theta minus sine theta, all over cos theta minus sine theta. And we should notice that I can cancel these two, okay? So I can cross this off with that. And what I'm left with is just my cos theta plus sine theta, which is essentially the same as sine theta plus cos theta because addition is commutative. And this is just equal to our right hand side. And what do we conclude with? You guessed it. Well, that was quite easily done. Okay. So I hope you've learned something. Okay. I hope you can take away quite a lot of techniques with how to solve these questions. I took you through 4 progressively harder questions, and hopefully using these techniques you should be able to essentially do anything with these types of questions. So I wish you the best of luck with them, and enjoy your day. Thank you.